balance of mass and energy in nuclear reactions. Okay, now let me share my screen. Okay, I hope you are able to see my screen now. Here, yeah, it's
Yes,
visible.
sir.
Okay, so right now, what is a nuclear reaction? Right, in a nuclear reaction, uh, start with nuclear reactions. In a nuclear reaction, you have the nucleus, which is usually termed at termed as X, capital X. You have an energetic particle termed as small x. This particular particle goes and hits the nucleus, and then after the hitting, you have two particles which are produced. One small y, which we call as the ejectile, and the other particle is termed capital Y, and it is called as a residual nucleus. Okay. Hmm? So you have you have one particle here, one nucleus here. The project this small particle comes and hits the nucleus, and after the hitting has taken place, you have two particles which are produced normally, and one is known as the capital Y is known as the residual nucleus, and the small y is known as the ejectile. So similarly, this is called as the target. This is the target nucleus, and this small x is known as the projectile. Okay. Now, it is not necessary that whenever a projectile hits the target nucleus, whenever the projectile hits the target nucleus, an ejectile and a residual nucleus are formed. Only if the projectile has sufficient energy can this reaction occur. Okay, so we will calculate that and see what is the energy required for this particular disintegration to occur. Okay, it's called as nuclear disintegration energy, and that is what we will derive today. Now, in 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 short form, a nuclear reaction can be written like this: target nucleus, projectile, ejectile, residual nucleus, where X is target nucleus, small x is projectile, small y is your ejectile, and capital Y is your residual nucleus. Is this clear? Yes?
Yes, sir.
Yes, sir.
Hmm?
Yes, sir.
Yes, sir.
Now we want, and you know that there is something called as law of conservation of mass and law of conservation of energy. Correct? Hmm? So if a nuclear reaction occurs, suppose it occurs, then the law of conservation of mass and energy has to be satisfied. So energy and mass have to be conserved. Okay. So now we will see how this energy mass conservation takes place. Right? So here is, you have the small projectile. It hits the target nucleus, produces a ejectile and a residual nucleus. Okay. Now the projectile X has rest mass energy given by m small x into c square, and this particular particle has a kinetic energy which is denoted by E small x. So total energy of X, because it is moving, it has kinetic energy plus mass, rest mass energy. So total energy for X is going to be Ex plus mx into c square. Is this understood?
Yes, sir.
Yes. Okay. Now, so we know the total energy of small x, which is the projectile. Now we assume that the target nucleus is at rest. Because it has rest, the kinetic energy of the target nucleus is zero. It has only rest mass energy. It has only rest mass, and the rest mass of X is going to be m capital X into c square. Is this clear? So total energy of the reactants, total energy on the LHS, is going to be projectile energy, which is E small x plus m small x into c square plus m capital X c square. Is this clear? Yes? Yes or no? Alright, I'll just reduce this so that you see the complete equation. Yes or no?
Yes,
Understood?
sir.
Now
Yes, sir.
let's do this. Let's do the same thing for the RH side, right hand side. In the right hand side, you have the ejectile. The ejectile moves with some kinetic energy. So the, and it has some rest mass. So ejectile has a rest mass which is given by m small y c square. Ejectile has a kinetic energy which is denoted by E small y. Someone dropped in Google Meet. कौन है बाबा? धीरज यादव. Okay. So here I am. So kinetic Y is the ejectile. Ejectile has a rest mass of m by c square, and the kinetic energy is E small y. Similarly, I have the residual nucleus. Now this residual nucleus is not found at rest, it is found to be moving, so it has some kinetic energy. So the rest mass of the nucleus, residual nucleus, can be given as my into c square, and its kinetic energy is given to be m capital Y, it is denoted by E capital Y. Okay, is this understood? So now total energy on RHS has to be equal to kinetic energy of small y plus rest mass energy of small y plus kinetic energy of the residual nucleus plus rest mass energy of the residual nucleus. Is this clear? Now, since energy and mass have to be conserved, then these two have to be equal to these two have to be equal. The total energy on the left hand side and the total energy on the right hand side have to be equal. So that could be written as the total energy of the projectile plus the rest mass energy of the target nucleus has to be equal to rest mass energy plus kinetic energy of the residual nucleus plus kinetic energy plus residual plus rest mass energy of your ejectile. Is this understood? All I have done is I have equated the energies. Total energy on the left hand side has to be equal to the total energy on the right hand side. We define something called as the nuclear disintegration energy. We define something as the nuclear disintegration energy. We call it, we give it a name, Q, denoted by Q, and it is equal to change in the kinetic energies. So it is equal to change in the kinetic energies. It is equal to change in the kinetic energies, where E capital Y is the kinetic energy of the residual nucleus. E small y is the kinetic energy of your projectile, of the ejectile, and E small x is the energy of kinetic energy of the projectile. And Q is called as nuclear disintegration energy. It is also called as Q value. we'll be studying something called as Q equation also. So remember, Q value and Q equation are different. Q value is nuclear disintegration energy. Okay, so we will derive an expression for Q now. Now, if you look at the top, if you look here, if you look at the expression here, the one underlined in brown, you will see that we have terms for E small y, we have terms for E capital Y, we have terms for E small x. Now what I can do is, I can easily find out this from the equation which I have underlined in brown. Is that clear? So when I do that, okay, so let's do that now. So we will have, let's have a look at that expression. The expression looks something like this: kinetic energy plus rest mass energy of the projectile plus rest mass energy of the target nucleus was equal to kinetic energy of the ejectile plus rest mass energy of the ejectile plus kinetic energy of residual nucleus plus rest mass energy of the residual nucleus. Okay, now what I can do is I can transpose this Ex on the other side, so I will have Ey plus E capital Y minus Ex will be equal to sorry, mx c square plus m capital X c square minus m small y c square minus m capital Y into c square. Now this can easily be written down as mx plus mx minus my plus my into the whole thing into c square, and so this is the expression for your Q. Is this clear? This is Q value, the expression for Q value or nuclear disintegration energy. If Q is greater than 0, now see, we know all these rest masses of the nucleus by using something called as mass spectroscopy. Okay, there is this Bainbridge mass spectrometer and other mass spectrometers from which you can find out the energy, the masses of all the nuclei, and the masses of all the nuclei are known to us. So we know all these masses, the terms like small mass of projectile, mass of ejectile, mass of residual nucleus, mass of the target nucleus are all known to us. So we can easily calculate Q. And if Q turns out to be 0, we say that the reaction is exoergic. Exoergic which means energy is released. Oops. Exergic, which means energy is released when that particular nuclear reaction occurs. Okay. If Q is less than 0, then energy is not released when such nuclear reaction to occur. Energy has to be supplied. Is the Q equation. Now, if we ever have exams like this semester, and then your semester exams, if they are, for like summative type where you're writing those answers and not MCQ type, then this is usually asked for 8 marks, 7 to 8 marks. A derivation from the start till this particular point, where you have derived Q value or nuclear disintegration energy. So up to this, it is asked for 8 marks, right? So this ends our derivation for the nuclear disintegration energy or Q value. Now let's solve certain problems. Okay. Okay, let's solve some problems. Okay, find let's so here is problem number 1. Find the Q value. Find the Q value of the reaction. The reaction given is 7 nitrogen, 14 alpha, proton, 17 oxygen, 8 sorry 17 18 2 8 9, correct. All right, and it is given to you that the mass of the alpha particle comes out to be 4.00263 atomic mass units, AMU. Mass of your nitrogen nucleus is 14.0031 atomic mass units. Mass of the residual nucleus, which is oxygen. Mass of oxygen comes out to be 16.994 AMU, and mass of proton comes out to be 1.007825 U atomic mass units. Is that clear? Now you have been asked to find out the Q value. Now the Q value there are two formulas for the Q value. One, which we know, is Q equal to EY plus E capital Y minus EX. This formula has to be used only if we know the kinetic energies of the particles. So since we don't know the kinetic energy of these particles, we cannot use this formula here. Now the other formula known to us is given by Q equal to mass of the projectile plus mass of the target nucleus minus mass of ejectile mass of the into c square. Okay, so we know this. Now I hope you have already had some few lectures on nuclear physics, and I hope you have done what at 1 AMU is, and I hope you remember that 1 AMU was approximately 931.5 MeV. So 1 AMU is 931.5 MeV. Okay, so the Q value of the equation comes out to be mx plus m capital X minus my plus m capital Y into 931.5 MeV, because we have converted here. We know that 1 AMU, the energy equivalent is 935.5. What that means is 1 AMU C square, 1 AMU into C square in joules comes out to in electron volts comes out to be 931.5. So we know that. So we'll use that fact here. Now all you have to do is substitute for all these values that are given and tell me what the final answer you get. So here is the expression. Can anyone tell me what the final value comes out to be? इसका मास है 4.002603, ठीक है। दूसरे का मास है 14.0031, थर्ड वन इजेक्टाइल का मास है 1.007825 और इसका मास है रेसिडुअल न्यूक्लियस का 16.994। इसको ये सब मासेस एएमयू में है, इसलिए मैं डायरेक्टली 931.5 से मल्टीप्लाई करेगा। तो तुमको क्या ये टर्म कम मिलता है क्या? आई थिंक दिस सब्सट्रैक्शन कम्स आउट टू बी नेगेटिव। ये है यहाँ पे ब्रैकेट है, यहाँ पे एक बार चेक करोगे?
Yes, sir.
हाँ, चलो बोलो क्या था आंसर। नंबर्स ऐड ही करने का, और कुछ करने का नहीं है। एंड देन यू हैव टू मल्टीप्लाई। See, it is 4.002603 plus 14.0031 minus 16.994 plus 1.007825 comes out to be 0.003878 into 931.5. So I am getting it as 3.61 MeV. Is that clear? So the final answer for this comes out to be 3.612357
Yes. AMU.
MeV. So this reaction, if it occurs, it is going to release energy. Okay.
Yes, sir. Now understood.
Okay. So this is your exoergic reaction.